All right, so this week we're going to be talking about modules and packages in Python. And as usual, if you have any questions, please throw them in the chat, and I'll be happy to answer those at the end of each slide. These slides were created by Gaurav a while back, so huge thanks to Gaurav for the help with creating these, and I will be presenting them today. Cool. All right, so a module is a file which consists of Python code. Basically, any of the Python files that you've been creating so far could be considered a module. So if we had a file called hello-world.py, you could consider that a module. And a module allows you to organize your Python code logically. It's a good programming practice to keep related code together in a file, and then, along that same vein, separate out functions and things like that that aren't necessarily related into separate files. So in this particular example here, Gaurav has a folder that says PPiAI, in that he has another folder college, another folder for VN, and then he has assignment4.py, that's one module, input and output.py, that's another module, and loops.py, another module, and then he has some text files in here. Those aren't considered modules because they aren't Python files. So a Python, in order for it to be considered a module, it must be Python code within that file. So with modules, if you want to bring the code in from a module, you would use the import statement. So we've seen this before in previous weeks where we talked about like importing the OS package or importing the arrays package in order to use arrays in the earlier weeks of the course. But yeah, you can use any Python file as a module using the import statement. So in this loops.py file, say for whatever reason we wanted to import something that's in the assignment4.py file. In order to do that, all we really have to do is type import assignment4. And on the previous slide, since these were in the same folder, we're able to find that our loops.py file is able to find our assignment4.py file, no problem. So we just import assignment4 and we leave off the .py there. And then once you've imported that assignment4 file or that assignment4 module, then you can access any of the variables that are defined in that module using the dot operator. So in this particular case, in the assignment4.py file, we have welcome text1 equals, so we're assigning a variable called welcome text1. We're assigning it the value I am assignment4 or I am assignment.py module variable 1, and then in welcome text2, we're assigning that variable I am assignment.py module variable 2. So now if we want to access one of the variables that exists in assignment4.py, all we have to do is print assignment4.welcome text1. And when we run this file now, when we run the loops.py file, and we can tell that we ran the loops.py file here because that's what shows up in the executable line up here, then we see that we get output I am assignment py module variable 1 because we printed welcome text1 from the assignment4 module, and so we referenced this variable here. Cool. So if there are any questions, again, please throw them in the chat, but not seeing any so far, so just going to keep chugging along. So more on the input statement. When the interpreter encounters an import statement, what it's really doing is it's executing the entirety of the code in the module that you're importing. So in this particular case, previously on the previous slide, we just had these first two lines of welcome text1 and welcome text2. So those were executed, and those variables were then accessible through the assignment4 file or the assignment4 module. But if we put a print statement in our assignment4.py file, so here we're printing welcome text2, and then when we import assignment4, what happens is this code is all executed, and we get whatever print statements or any actionable statements basically that are in assignment4.py are executed as well. So we print welcome text2, and then we're also still in our loops.py file, we're still printing assignment4.welcome text1. So what happens then when we execute the loops.py file is that we get I am assignment py module variable 2 because of this print statement here, and then after that we get I am assignment .py module variable 1. So something to call out here is to check out the order. So it first prints the statement of the imported module. So that's because we have our import assignment for first, and it executes the entirety of the code in the assignment4.py file. So then it prints welcome text 2 first, and it's printing that as part of the import assignment 4 here, because we're importing that module over here. And then we're printing assignment4.welcome text 1. So that's why we get the line of I am assignment py module variable 2, then I am assignment py module variable 1. It's because the import prints welcome text 2, and then this actual print statement in loops.py is printing assignment4.welcome text 1. So that's how we get the specific order here. So just keep in mind that anytime you import a module, all of the code in that module is technically executed. And so if there's any print statements in there, we'll see those print statements in the file that is importing the module. Cool. Still not seeing any questions, so keep moving. So the from statement. So Python's from keyword lets you import specific attributes from a module into the current namespace. So something you'll have noticed on the previous slide is that we always had to prefix welcome text 1 with assignment 4. And we did assignment 4 dot welcome text 1, so we used our dot notation to access welcome text 1. But here, we really just want welcome text 1, right? We only want to print that, and maybe we want to avoid printing this welcome text 2 that's here. So let's see what happens. So with Python's from keyword, you can import a specific attribute from a module. So here we can do from assignment 4, import welcome text 1, and now we can access welcome text 1 without the dot notation. So we don't need to use our dot operator anymore when we do from assignment 4, import welcome text 1. And this is something that you may have seen. In other use cases where you're like when you just import OS. When we do import OS, you have to do like os.walk, right? If you knew that you were just using the walk function there, then you could do from OS import walk, and then you could just access walk directly without having to do os.walk and things like that. And you can use the star or asterisk or splat. You'll hear people call it all of those things. You can use that symbol to import all names from a module, and then you don't have to worry about specifying exactly what you want to import here. But then you also don't have to prefix the references to those variables or functions or whatever it might be that you're using from the module with the module name. So in this particular case, we say from assignment 4 import star. And then we can still print welcome text 1 without having to prefix it with assignment 4 dot. And something else we could do here now, since we did the star, is we could also print welcome text 2 without prefixing it with the assignment 4 dot. Up here though, in this example where we did from assignment 4 import welcome text 1, we would not be able to access the welcome text 2 variable because we've only imported this particular variable into the namespace. It's only when we're using the star, or if we specified welcome text 2 in this import statement up here, that we would be able to access welcome text 2 in the loops.py file. So hopefully that makes sense. Let's see, it looks like we got a few questions. So is import only used at the top? So generally, yes, that's going to be a best practice that people follow, is to import all of your modules and packages at the very top of your file. Oops, I didn't mean to go forward just there. Or I went back. But yeah, that's best practice, is to do all your imports at the top of the file. There are very rare cases where you'll have to import something later on in a file, but it's general best practice to import it at the very top of your file. And if you run into some situation where you need to do some operation before you can import a package, then that's where you would put an import lower down. But in PyCharm, if you try to put an import in the middle of your file, it's going to give you a warning. It'll underline it in gray, saying something about like, this import is in the middle of the file. It should be at the top of the file. So yeah, best practice to put it at the top. You don't have to. No one's going to stop you. Python definitely won't, but you should, as much as possible, keep them at the top of your file. How do we open two PY files at the same time? So if we want to like open two PY files in our PyCharm browsing window, there's a way to do that. You would like right click on the file and then you go to open in right split or something like that. So that's how you can have two Python files to view in the PyCharm editor. but I think what you mean is like how you might be able to import two modules at the same time. And really what you'll need to do there is you'll have to have two separate import statements. So say we wanted to, let's go back to a previous slide here. Say we wanted to import assignment4.py and input and output.py. If we wanted to import both of those, then we need to have two import statements up here. So we'd have import assignment4, and then on the next line, we'd have import input and output.py. So that's how you can import multiple modules, is you just kind of keep putting imports one after the other on separate lines. But you can import multiple variables from the same module on the same line. So in this particular case here, where we're doing from assignment4 import welcome text 1, if we wanted to also import welcome text 2, then we could just do import welcome text 1 comma import comma welcome text 2. Sorry, so it'd just be from assignment4 import welcome text 1 comma welcome text 2, and that would be importing both of those things that exist in assignment4. In this case, they happen to be variables, so that would be importing both of those variables from the assignment4 module, all on one line. So a couple answers to that question, and hopefully one of those answers was the one you were looking for. All right, so it imports files into PyCharm, or it can import from any other sources as long as it is a py file, i.e. the current IDE, not necessarily PyCharm. Yeah. So any IDE and any Python file will support these import statements. It doesn't have to necessarily be another file that's in PyCharm, but it does have to be available on your path. And path is like an environment variable. It's something you may have seen when you get certain errors when you're trying to install things, and it says like, or you install something and then you try to run it and it says something like, oh, make sure this is in your path. Basically, it has to be accessible to your Python file through some means, whether that's like an environment variable of your path or whatever that might be. But if you're creating your own modules, generally those are going to need to be in the same directory as the file that you're importing the module into. But if you can add that file, like you create a module and then you add it to your system path, then you could also import that without it needing to be in the same directory. So that gets a little complicated there, and we'll get more into into that when we talk about packages. So like, when we've imported OS didn't exist as a package in the same directory as our Python file when we imported OS, right? That's something that when we do like a pip install and we install a package to our system, and we'll get to pip install in a moment. It's just a few slides away. But when we do that, it installs it to our system path. So then it's accessible anywhere on our computer to any Python file that we write on our computer. Yeah, so hopefully that answers that question. I'm not seeing any other questions in the chat, but if there are any follow-ups to that, or if I didn't adequately answer any of the questions that you've asked, please ask a follow-up with like a clarifier of what I missed. Thanks. Cool. All right, so packages. A package consists of multiple Python files. Basically, it's an entire folder structure that consists of modules. So in this particular case, we have the PPiAI broad folder. This is our root folder of our project. But then within that, we have the college folder, which could be considered a package if it contains Python files. It doesn't, because you've all done the college assignment, and that just contains a bunch of like subfolders and text files and things like that. So that wouldn't be considered a package because it doesn't consist of Python files. But here we've created another PPiAI folder, and under that folder we have module 1 and module 2. So now PPiAI, this PPiAI, not the broader one up here, this is the project folder. This one here is now a package because it contains some modules within it. So it's like a way to have multiple modules packaged into a single directory. So we call that a package because it packages them up nicely. Cool. Keep moving along. So when it comes to importing a package, since a package consists of multiple Python files, so it's an entire folder structure that consists of modules. So in this particular case, Just like we showed on the previous slide, we have this PPiAI package, and within it, we have two modules, module1.py and module2.py. So if we want to import module one, so if we're in module two, then we can just directly import module one because they're in the same directory here. So I can access module one from module two because they are in the same package. So module one is right here, module two is right here. Since they're in the same PPiAI folder here, we can just directly import module one into module two. And then we could print module one.welcome text one, assuming that module one has a welcome text one variable or function or something within it. On the other hand, if we're in assignment 4.py, because assignment 4.py is outside of that folder, so it's at the same level as the PPiAI directory itself or the package itself, then we need to, if we want to just import module one, we can do import PPiAI.module one. So we need to use the dot notation there. So if you're outside of the package, if you're outside of the package, then you need to give the package name prefixed onto the module name. And we don't have to do PPiAI.module one. What we could do here is we could do import PPiAI, and then we would still have the same thing down here where we'd have to print PPiAI.module one.welcome text one. You have to keep chaining together the dots as you go deeper into the package. But by importing PPiAI.module one, we're only importing module one here. We're not also importing module two. If we just did import PPiAI, then we would be importing both module one and module two, and we would be able to reference both of them in this same way of PPiAI.module one and PPiAI.module two, etc. So hopefully that helps to kind of understand exactly how you can go about multiple different imports and how you import specific things from a package. You could also use the from statement here. So we could have done from PPiAI import module one, and then we wouldn't have to prefix the module one here with PPiAI. And we could also do from PPiAI.module one import welcome text one, and then we wouldn't need to prefix welcome text one with PPiAI.module one. So you can you have a lot of flexibility here is basically what we're getting at in terms of how you can import things into your files from packages and modules. All right, not seeing any questions, so moving along. So multiple imports, package in a module. You can use a comma to import multiple modules or packages in one line. So, okay, yeah, this is something I had forgot about. So here we have package 2 and PPiAI. They're both two separate packages. So here we can import PPiAI and package 2 if we want to import everything from PPiAI and everything from package 2. It really gets into if you want to import specific things from there, then that's where you have to, where you'd have to do from PPiAI import module 1, and then from package 2 import whatever is in it. So if you have to use a from, then you can only have from one blank basically. So you can only have, if you do from blank import, then you can only have one thing in that blank. But if you're importing the entirety of a package, you could import PPiAI and package 2. Generally, it's best practice, though, to separate them out into multiple import statements. It doesn't hurt the functionality of your file to have import PPiAI on one line and then import package 2 on another line. This is just something that we want you to be aware of. And this is importing, and just to call out, this is importing packages up here. And then down here, we're importing modules, because remember, loops and input and output are files that are at the same level as our assignment 4.py file. So that makes those modules because they're just simple Python files as opposed to a directory of files. You can also use the as keyword to refer to an imported module by a custom name. So in this particular case, if for whatever reason we wanted to import PPiAI.module1 as my module, so we want to reference PPiAI.module1, we want to reference it by using the variable name my module throughout our code, we can do that. We do that with the as. So this is kind of like aliasing the PPiAI.module1 import. So then we can just print my module.welcome text 1 because we've now aliased PPiAI.module1 with the value my underscore module. So we have a ton of flexibility with how we import things. And there are some cases where you want to do this, because There are some packages that have functions that have the same name as a function from a different package or something like that. And so you want to have a way of differentiating those package names. So say you're importing two different math packages for whatever reason. Like say you like how one of them does like a linear regression, but you like how the other package does like a random forest machine learning algorithm or something like that. But say they have conflicting things within those packages, like, you know, the first package that has the linear regression you have in it, it also has a random forest function in it. And then the one where you're importing the random forest one that also has a linear regression thing in it, you can then alias those imports so that you can tell which package it came from, basically, and you don't have them shadowing each other, and you don't have any confusion about which package you're using the random forest from and which package you're using the linear regression from. So that's where the custom names are really helpful. It also helps a lot when you have a package that has a really long name. There are some packages out there that have, you know, super long names to them because maybe the person who created the package like wanted to be very specific about what the package does, and you don't want to type out that whole package name every single time that you need to use it. So you just import it as some shorter name. This is also something that happens very commonly in data science. So in data science use cases, people use a package called pandas and another package called numpy pretty regularly. And if you're drawing on the screen, if you could please not do that, that would be awesome. I'm gonna have to stop sharing for a moment and reshare. All right, we're back. Okay, so yeah, there's these packages numpy and pandas. So for numpy, people typically do import numpy as NP, and that's just a convention in data science and data analytics spaces. And then for pandas, people often do import pandas as PD, another convention in data science that people tend to follow. So it's just something to be aware of because you'll see certain conventions like that across different industries. Like you'd almost never see someone do like just import pandas and then do pandas.dataframe. They'll always do import pandas as PD and then they'll do PD.dataframe. And even in their documentation, you'll always see PD.dataframe or whatever. They're kind of expecting that you're always going to use that same alias for that package. So you'll see cases like that just to call out. But yeah. All right, so some questions. Can we import specific class or functions from a module? Yeah, absolutely. You can import specific classes and functions from a module with ease. So it's basically the same way that we imported the specific variable on this slide, where we just imported the welcome text one variable. If welcome text one happened to be a function or a class, we would be able to import it in the same way. So you could do like, you know, from assignment 4 import function one, or from assignment 4 import class one, or things like that. So yeah, anything, you can import anything using this like from blank import blank approach. So you can import variables, classes, functions, whatever it might be. Great question. Okay, cool. So not seeing any other questions. We're gonna move along to this one. Why are packages and modules needed? The answer is modular programming. Modular programming refers to the process of breaking a large, unwieldy programming task into separate, smaller, more manageable subtasks or modules. Individual modules can then be combined like building blocks to create a larger application. So the advantages of this are simplicity, maintainability, reusability, and scoping. So it makes things a lot simpler to have. So say you're creating a math package, and in that math package you have stuff around like, you know, machine learning. So you have your broad package is called math. Underneath that, you have a file that's machine learning. And within that, you have a bunch of machine learning algorithms or something like that. But then you also have another file that's just like, algebra or something. So then you have a bunch of functions that are related to algebra in this separate file. And then you have in this separate module. And then you have another module in there that's related to calculus. So you have another file in that package That's like calculus.py. And this way you can separate out the different math principles or whatever within there. And it keeps it nice and simple because you can tell like, hey, I'm doing a machine learning use case. So from my math package, I want to import the machine learning modules because I only care about those. Or say you're doing an algebraic use case. You just do from math, import algebra, or a calculus use case, same thing, from math, import calculus, things like that. So it keeps things simple for the user and also simple for you as the person writing the code, because then you're like, oh, hey, I realized there's a bug with my machine learning code. Let's go in and fix that bug. And that's where the maintainability comes in. You don't have to go search through one file that's like tens of thousands or hundreds of thousands of lines of code. You know that you have to, your scope of where you need to look is narrowed down to just the machine learning module within that package, because you just need to fix a machine learning algorithm or something like that. Also, the reusability. So, a lot of machine learning algorithms, they use principles from algebra, especially linear algebra. So maybe in your algebra module, you have some linear algebra related functions in there. And then in your machine learning package, you need to use some of that linear algebra. So instead of having to write the code again within your machine learning module, you can just import the code from your algebra module, because you need to use that linear algebra functionality from your algebra module. And then same goes for any other use case. So something like with the OS package, we didn't have to go in and write the code to actually implement os.walk. We were able to just use the code that somebody else wrote and took a ton of time to optimize and figure out exactly how to get it to work on a computer level. And we just go in, import that package, and now we're able to use all the code they wrote. We're able to reuse it as much as we want. So that's where the reusability comes in, and you're keeping it dry. That stands for do not repeat yourself. And then you're not having to repeat code that's already been written. Basically, you can just reuse it in another place by importing it from whatever module or package it was originally written in. And then also for scoping, like I was saying earlier, you have a math package and you want one module that's scoped to just machine learning, another that's scoped to just algebra, another that's scoped to just calculus. It keeps it really easy to keep those things logically separate, so that if you're creating a file that all you need in it is some machine learning stuff, you don't need to also import algebra and calculus, because you don't necessarily need something from those. So yeah, it helps you scope it to just what you need, basically. All right, looks like we have a question. How different is it from object-oriented programming? So they kind of go hand in hand. So with object-oriented programming, you're creating objects, you're creating classes, and those objects and classes have properties and things like that. But oftentimes what you're going to do is you're going to put that class in a specific module. So typically what people will do with modular programming and combining it with object-oriented programming is they're going to have a broad folder for their package. And within that package, they might have multiple classes. So as an example, like say you have a package that you're calling animals or something. And then within that you have a module that's just called mammals or something. And in mammals, you have a class that implements what a mammal is. And then you have another module that just has a single class of dog or something like that. And that dog is going to inherit from and extend the mammal class, but they're still keeping them separate as logical separate modules. So it's still keeping it simple, maintainable, reusable, and scoped. And then you can keep having like more and more modules within that animal package for different mammals. And then say you want to, throw in something that's like reptiles. So then you have another reptile class. And then that's like a base class that you can use to build out something like, lizard, crocodile, whatever it might be. So they really go hand in hand is what I'm getting at. Module programming and object-oriented programming go hand in hand. And it makes a lot of sense for maintainability and readability to keep each of your objects separated into a distinct module. So you'd have a single class per module. That's a good coding practice to get into. It's not absolutely required, but it's a great practice, and it's something that I try to follow. So are imports the same as extensions? Great question. So not exactly. When you you'll need to, so in that example that I used, I had the mammal, I have the mammal class, and then I import that mammal class into, and so I have that mammal class in a single module, and then I have a human class as another module. So humans are a type of mammal. So instead of reusing the code that I wrote about for the properties of a mammal, I can just extend my human class extends the mammal class. But in order for it to extend that mammal class, because it's now in its own separate module, I'll need to import the mammal class into my human module. And then when I write my human module, it'll extend, it uses as a base class the mammal class. And I can't quite recall how much of this was gotten into in the classes lecture last week, just because I wasn't here. But basically, whenever you create a class, you have like your class, and then you have the name of your class, and then you have the parentheses after it. If you want it to extend another class, whatever class it's extending goes into those parentheses. So now it's a subclass of the class that was passed in as the parentheses there. It has all the same methods and properties of that parent class that it is subclassing. And then you can write further properties and methods and things like that for the subclass itself. It gets kind of high level, so I'm not sure if that was included in the lecture last week, but definitely something to look into. It's a very useful programming practice, especially in terms of reusability and maintainability, because every mammal shares certain properties, right? Like we all, like all mammals have hair or fur. All mammals have mammillary glands, things like that. 99% of mammals give birth to a live animal, a live offspring, instead of a like egg or something like that. So there are certain properties that are easily inherited by any mammal that subclasses the mammal module. So that makes it so that writing a dog and writing a human class, you don't have to specify in both of them they have fur or they have hair or whatever. They just that's specified because they inherited from the mammal class, which all mammals have some hair or fur, right? Hopefully that helps and didn't get too in the weeds. Cool, not seeing any other questions. Gonna keep moving. All right, Python packages. So Python is very popular among developers nowadays, as you might have come to realize throughout this course. And one of the reasons to that are the mature, pre-written, easily available packages to do any task. So Pandas, talked about this earlier. Pandas is an open source data analysis and manipulation tool. NumPy, and these are all packages that I'm going over. NumPy is a library that supports multidimensional arrays and matrices. It has high-level math functions. So a lot of the things that I was talking about with like linear algebra and stuff, it has functions for that kind of thing. The requests package. So requests is an HTTP library for performing various HTTP actions with ease. And the HTTP actions are used across the internet, like not all, but a good portion of websites are just, they're all gonna, well, I guess all websites are gonna be HTTP or HTTPS related, but there's also APIs out there that use HTTP as their protocol for interacting with that API. There are other types of APIs out there, like SOAP APIs and stuff that we won't get into, but HTTP is basically how you're navigating the internet. And you can use requests to programmatically navigate through the internet. So Flask is another package. So Flask is a micro web framework used for web development use cases. So if you're trying to create you're trying to build a website and you want to use Python as your backend for that website, you can use Flask for that web development use case. Flask is really lightweight. It's really small. It can help make your website really fast. It just isn't as feature rich as some other packages out there for web development. Like there's Django, and that's like DJANGO. Django is another web development framework that's not quite as lightweight as Flask, but it's more feature rich and things like that. So there's tons of other packages. We've already talked about OS. That's one of the packages. We've talked about arrays. That's another package. And I could keep going all day. Literally, I could go all day on different packages that are out there. Just look it up and you'll be able to find some. Some packages come pre-installed when you install Python, so you just need to import them. So some packages that come pre-installed are IO. The IO package contains functions for operating system level operations, input and output operations, as we learned a couple weeks ago. Math, there's a math package, and it contains various predefined mathematical functions and values. There's the sys package. Sys package contains functions and attributes of the Python runtime environment. So that gets kind of meta there. You can dive into like things about Python itself and the specific Python environment you're working with using the sys package. Then there's the datetime package. The datetime package contains date and time related functions. So say you want to take a string, you want to convert that to an actual datetime object, you can use the datetime package, because the datetime package has a datetime object built into it. It has a class around what a datetime object is, how they behave, things like that. All of those come pre-installed with Python. So all you have to do is just like at the top of your file is do import datetime, and then you can use functionality that's built into datetime. You can do import math, and you can just use the functionality that's built into that. The ones up at the top here though, pandas, numpy, requests, Flask, those don't come pre-installed when you install Python. So what you'll have to do to install those is you have to use pip, and pip stands for pip installs packages. It's a recursive name. So pip is pip installs packages, and you install Python packages using pip. So you do like a pip install and then the package name. And I believe we'll be getting more to that in the next slide. But let me just check the chat. All right, not seeing any questions in the chat, so I'm going to keep moving. So yeah, pip, here it is. Pip is a package management system for Python that facilitates installing and managing Python packages. Its name is a recursive acronym. Pip equals pip installs packages. It comes pre-installed with most Python distributions, but sometimes you'll see a situation where you install Python and then pip isn't installed as well, and you have to install pip separately. There's a way you can install pip using Python, which is kind of interesting. You install pip using Python, and then you install Python packages using pip. I always thought that was interesting, but anyway. So if you need a package that isn't pre-installed with your Python distribution, we use pip to install it. So as I mentioned on the previous slide, requests doesn't come pre-installed with Python. So if you try to import requests at the top of your file without installing it first through pip, you're going to see it underlined in red here, which indicates that like there's no module named requests, basically. So it can't find a package or a module named requests. To fix that, you can do a pip install requests here. So then when I execute pip install requests, now it'll go find the request package. There's this huge repository out there of Python packages called PPiAI. That's PYPI. That's where this package lives, and then we can install it from there. Pip will know to go check pypi.org to look for packages. And yeah, so when I execute pip install requests, it'll install the package for me. Let me see if there's another thing here. Cool. Yeah, so now that I've run pip install requests, now my import is no longer underlined in red. It just says import requests. It's perfectly accepted. So we're good to go there. Like that's all you need to do to install a package that's not built into Python. And that's a little bit of an oversimplification. Sometimes these packages are not. Sometimes they aren't living in PyPy. Sometimes you have to install them, say, from GitHub or something like that. Gets a little complicated. The vast majority of packages that you need to install will be available through pip. It's when you get more advanced into programming that you'll see other situations like installing from private PyPy repos or installing from GitHub, things like that. So don't worry too much about it right now. If you run into that, a quick Google search should help you figure out what the issue is. But yeah, you can find and read about available packages and how to install and configure them on PPiAI.org. So if you want to see if there's a package out there, check out PPiAI.org. It's got a search functionality for finding packages, and it'll tell you exactly the line of code you need to use to import or to install it. Oftentimes there will be some documentation on like generally how to use the package. They don't get super in depth on how to use that package on PyPy. Some do, but it'll generally tell you, what the package is, how to install it, and how to import it, or something like that. Cool. Does it install locally to the project or globally? That's an excellent question. Globally is typically the case. When you do pip install requests, it's typically going to install it globally. There's a caveat here. So you'll notice here I'm in a venv. So where it says venv here, what's happening when I do pip install requests is that it's going to install it to my venv. It's not going to install it globally to my system. It'll install it to the virtual environment that I'm currently working in. So it really depends on where you're installing from. But if you open up like a terminal or a PowerShell or whatever it is on your computer, and then you just do pip install, pip install requests, that'll install it for the entire system. If you're doing it from a virtual environment, that'll install it to your local project. So great question. It depends. Yeah, generally you want to try to install it to the specific project because there's certain dependency issues. Like say you need a specific version of requests, you can do that by doing like pip install requests at and then the version number that you need. But yeah, anyway, it's best practice usually to install things to a virtual environment. And that's why we've been using virtual environments throughout the course. Cool. I'm not seeing any other questions, so keep moving. All right, additional resources, Python modules. Check out W3 Schools to learn more about Python modules. Python packages, check out this pythoncourse.eu website. There's Python 3 packages. They talk all about packages, how to use them and all that good stuff. Learnpython.org has some information on modules and packages. And pypi.org is a great place to check out what packages are available to you, what they do, how to install them, how to import them, things like that. PyPi is a great resource. Just take some time to learn how to navigate. All right. Another question here, it's an off-topic question. Is it possible to separately print a variable that's defined inside the method outside the class? If so, how? So you're trying to print a variable that's defined inside a method, but so I imagine what you're saying here is you have a class. Within that class, you have a method, and within that method, you have a variable, and you want to print the variable of that method. No, you can't do that because you could print a property of a class outside of the class, but you can't access a variable that's referenced within a method unless that method exposes that variable by, say, returning it or something like that. But that's a great question. Yeah, there's not really a good way to go about doing that. Without editing the source code, basically. If you edit the source code of the class, of course you could do it, because then you could edit the method so that it prints the variable there, and then when you run that method, it'll print the variable. But there's not a good way to do it from outside of the class without having access to the source code of the class. But yeah, great question. All right. Cool. So let's talk about the assignment. All right, so modules and packages. For the assignment this week, we want you to create a package in the project named geometry. Inside the package, create 2 modules. So for question 1, create a module called areas.py, and it has 3 functions in it. Function 1, calculate the area of a circle based on radius. Function 2, calculate the area of a rectangle based on length and width. Function 3, calculate the area of a square based on a side length. And then for question 2, create another module called volume.py that has 3 functions in it. Function 1, calculate the volume of a cylinder based on radius and height. Function 2, calculate the volume of a cuboid based on length, width, and height. And function 3, calculate the volume of a cube based on a single side length. And then for B, call the functions defined in both the modules from a Python file outside of the package. So note, you might want to import the math package to get the value of pi for calculating the area of a circle and the volume of a cylinder. You should be able to find these formulae for calculating the area of a circle, area of a rectangle, area of a square, volume of a cylinder, volume of a cuboid, and volume of a cube. You should be able to find those with ease just by a quick Google search. So if for whatever reason though you're struggling to find the formula for that, just let me know. I can help you find it. But use your Googling skills, and I'm sure you'll be able to find it no problem. So any questions on the assignment? Basically, we just want you to create a package. The package will have 2 modules. Each module will have 3 functions. And then we want you to have another Python file that's going to import the modules, and that's going to import the package and its modules and execute the functions that you have then imported from your package and modules. Hopefully it'll be a relatively straightforward one. All right, so anything that I can demo here. I want to we have 10 minutes left, so if anyone has time, or if anyone has questions or wants to see something, I'd be happy to spend the last 10 minutes doing a quick demo for you all. So if you have anything you'd like to see, please throw it in the chat. While people are hopefully typing out some things they'd like to see me demo, I just want to call out, I know we haven't been great about getting back to you all about your assignment feedback the past few weeks. We're going to be extremely flexible with how much time you have to catch up. There's the assumption that you might have some things that you need to improve on in each of these assignments. And now that it's I don't know, 3 assignments behind, that might be a lot to catch up on in a single week or something. So we're not going to expect you to just catch up, get, the right answers by next week or something. We're going to be very flexible with this. Yeah, so just know, we're not going to expect you, I'm going to spend some time after the lecture today to give feedback on all of the submitted assignments that haven't gotten feedback yet. But yeah, just know that we aren't going to expect you to get a passing grade on it within a single week for 3 separate assignments. That wouldn't be fair. So you'll have some time. So if you're stressing about that, please don't. All right, so we do have one question. Want to see how to create a new project. All right, so let me pull up PyCharm. All right, so it's actually pretty straightforward in PyCharm. So we have PyCharm here. I have a bunch of existing projects here that I've worked on in the past. But if I want to create a new project, I just come to this this original PyCharm window. So it's actually if I close out of PyCharm, let me just open it back up again. So this is the first window you'll see pop up is, after the loading screen, but you'll see this welcome to PyCharm. And then you'll just go to new project. And within new project, you'll give it a name. So I'm going to call this PPiAI. Underscore example. And then in here for the new virtual environment, you'll want to select new environment using virtualenv. You'll want to base it off of some base interpreter here. Whatever interpreter will work as long as it's a valid one. I'm going to use Python 3.9. And then you just click create. And this popped up on a different screen, so pulling that over. And then this is your new project. So you've got a new project created here. And you're good to go. Now you can start to create, new files within here. So, you might create for this assignment, hint, hint, you're probably going to create a directory, and you might call that directory geometry. And then within that, you're probably going to create a couple Python files, name them area and volume, and then put functions in there. And then in your main.py, you might edit this to do from geometry import, or you could just do import geometry or things like that. Anyway, that's enough hints for the assignment. All right, another question. Must the functions run actual calculations, or we just give the formulas? Yes, they should be able to run actual calculations. So the expectation here is you're going to basically have, let me get rid of this breakpoint. You're basically going to have like, so you have a function called area of circle that'll accept a parameter for the radius. So say I put in a radius of 2, the executing this code should then return, like, obviously I haven't actually implemented the area of a circle, I haven't imported it or anything like that, but executing this should then return whatever the area of a circle with radius 2 is. So it should actually do the calculation and return the value of that calculation. Great question. Unrelated to this week's assignments, when do we have to do docstrings? Do we comment every function or class? When is it necessary? Great question. Technically, it's never necessary, but as a best practice, you should always include a docstring. Every single function you write, every single class you write, every single method you write, include a docstring. You'll thank yourself later. It's one of those things that it just feels like tedious work when you're writing it, and it's definitely not the most fun to write a docstring. But every time you create a class or a function or a method, if you include a docstring, you're going to thank yourself later when you have to come back and fix something in that code, or when you need to make changes to that code, or when you you create a package and then you don't use it for a year or two, and then you come back and you want to use that package again and you don't remember what it has. Having those docstrings are going to help you a lot. So yeah, write a docstring on every function and every class and every method that you write. And first off, you'll thank yourself later, and your coworkers will absolutely love you, because that makes it really easy to understand your code and see what something's doing without having to read through code. Reading something in a docstring format that's written in English or whatever native language someone speaks is a whole lot easier to understand than trying to read through the logic of Python code and understand exactly what's going on. But yeah, great question. Any others or anything else I can demo here? All right, well, I'm not seeing anything, no one indicating. And yeah, thank you for the welcome back. It's good to be back. Had a great trip and feel nice and refreshed. So happy to be back, and I hope you all had a great last couple weeks. I hope that things went well for the lectures that Vraj covered, and huge thanks to Vraj for taking the time to cover those. Our other option would have been just having you all read or view the lectures from previous terms, and that's never a great place to be, because then you can't ask questions live. But yeah, so thanks to Vraj for doing that. And we can call it for today. So I hope you all have a great rest of your weekend and an awesome upcoming week. I will talk to you all next week for week 11. Next week will actually be, I believe next week will be our last lecture. Yeah, next week will be our last lecture. And then like the Saturday after that, we'll have another meeting, but you don't necessarily have to show up. That'll be more so like tying some final things up, questions on assignments or whatever, just making sure that you all can get everything out there. And then after that, we'll be sending out certificates of completion. So, congratulations to all of you who have made it this far in the course. You should be very proud of yourself for doing all the hard work that it took to get here. Cool. So have a good one, everybody. Talk to you next week. Bye.